On July 15, 2025, at precisely 5:34 am, Beijing time, China marked a significant milestone in its journey to becoming a space superpower. The launch of the Tianzhou-9 cargo spacecraft from the Wenchang Space Launch Site in Hainan Province reinforced Beijing's ambitions for long-term human presence in space. More than just a resupply mission, Tianzhou-9 is a testament to China's logistical mastery and its readiness to sustain its own space station Tiangong for decades to come. Tianzhou-9, precision and power in orbitriding aboard the Long March-7 Y10 rocket. Tianzhou-9 reached low Earth orbit just 10 minutes after liftoff. In a feat that highlights China's advanced automated docking capabilities, the cargo craft successfully docked with the Tiangong space station's Tianhe core module only 3 hours after launch. This rapid rendezvous underscores the Chinese space program's increasing technological maturity and the reliability of its orbital infrastructure. This mission marked the fourth cargo delivery to Tiangong since the station entered its operational application and development phase. The successful resupply once again demonstrated the Chinese Space Agency's ability to execute complex missions with precision and consistency. A payload for the present and the future Tianzhou-9 carried between 6.5 and 7.2 tons of supplies, both essential and advanced. Among the most critical cargo items were 2 next-generation extravehicular activity EVA spacesuits. These new suits offer increased durability, support up to 20 spacewalks, and have a lifespan of 4 years. This upgrade will be crucial as China extends its human spaceflight missions in duration and frequency. Another key delivery was a new core muscle training device designed to help astronauts maintain muscle strength while in microgravity. Physical deterioration in space remains a major challenge, and this equipment supports China's ongoing research into astronaut health and long-duration spaceflight. One of the mission's most intriguing scientific payloads was a brain organoid on a chip experiment, a miniature, bioengineered brain model designed to study how microgravity affects human neurological function. This experiment could offer critical insights into the effects of space travel on the brain, potentially guiding future countermeasures against cognitive and neurological decline in astronauts. In addition, Tianzhou-9 carried nanocarrier-based drug delivery systems, materials, science experiments, aerospace medicine equipment, food, oxygen, and propellant. These supplies support not only the current taikonaut crew aboard the station Shenzhou-20, but also ensure Tiangong's continued orbital adjustments and habitability. Tiangong, from concept to global competitor, Tiangong represents China's first fully modular and permanent space station, made up of the Tianhe core module and 2 laboratory modules, Wenchang and Mengtian. This modular structure allows for expansive research in microgravity sciences, advanced technologies, and human biology. Crucially, Tianzhou missions like this one form the logistical backbone of the Tiangong program. With a resupply capacity exceeding 6.5 tons and autonomous docking features, Tianzhou is comparable in capability to international systems like SpaceX's Dragon, Russia's Progress, and Northrop Grumman's Cygnus spacecraft. China's strategic autonomy in China's space program continues to operate independently of Western cooperation. U.S. legislation barring NASA from working with China has only strengthened Beijing's resolve to develop a self-reliant space ecosystem from spacecraft and rockets to launch facilities and mission control. This autonomy is now yielding global attention. China's record includes placing rovers on both the Moon and Mars, constructing the world's largest radio telescope, and launching a lunar relay satellite. Each Tianzhou mission not only enhances the Tiangong station's operational stability, but also trains China's astronauts and engineers for deep space exploration. Global implications and emerging alliance with the International Space Station ISS scheduled for decommissioning by 2030, China's Tiangong is poised to become the world's only operational space station. This strategic position opens up new diplomatic opportunities. China has expressed interest in allowing other nations, particularly those in Asia, Africa, and Latin America, to conduct research aboard Tiangong. Such initiatives could shift the geopolitical dynamics of outer space, fostering new alliances while reducing global reliance on the aging ISS. For countries without established space programs, Tiangong offers a rare and valuable opportunity to engage in orbital science and innovation, preparing for the next leap. Lunar ambitions. In addition to its near-Earth aspirations, China's space program has set its sights on the Moon. Future missions such as the expected launch of Tianzhou-9 in 2025 will rotate crews and prepare astronauts for lunar expeditions by testing life support systems and logistical readiness aboard Tiangong. China's goal is clear: send taikonauts to the Moon before 2030. The experience gained from Tianzhou and Shenzhou missions is paving the way toward this next great leap. Conclusion: a new era in space exploration. Tianzhou-9 launch is more than a technical achievement, it's a symbol of China's accelerating space dominance. With consistent success in human spaceflight, orbital logistics, and biomedical experimentation, China is steadily cementing its place as a leader in 21st century space exploration. While the Tiangong station may still be growing, it already represents a cornerstone of China's long-term strategy to shape the future of human presence beyond Earth. Tianzhou-9's success not only supplies a space station, it fuels a vision, one that may soon see China planting its flag on the Moon, and eventually beyond.